Hello everyone, this is chapter 2 of my ESP8266 series, where I will introduce ESP8266 to you and what you can do with it, right? Starting with the traffic light, which is what we are going to discuss now, and the sensors for temperature and humidity. And then we have the IoT light switch, and also the whole greenhouse that can be automated through this ESP8266. And finally, an Arduino-like game console can be constructed and loading some Arduino programs to play some games. So let's start chapter 2, the traffic light. This is the wiring diagram created by a program called Fixing. It's very useful. You can search it and try to understand how to use it. To make this traffic light, we need the following list of parts, and we'll go through that one by one. The first one is the ESP8266, our microcontroller, and we'll purchase a board called Node MCU D1 Mini. Then we have the breadboard. We need to use two of them placed together so that we can put in the board. And then we have some wires. These are wires that can be bent easily, so you can fix it up and mold it. Then we have the LEDs. We need the red, green, and the yellow LED for our traffic light. And then you have for the resistors. We need the 1K resistor, 470 ohm, and 220. The breadboard has two sections, the top section and the bottom section. Within each section, the vertical columns, all the 5 holes there are connected. We are going to make use of two boards and connect them together using the notches on the side, and we'll remove the sticky tape on the bottom, stick into a plastic board so we can secure it. Let's take a closer look at our ESP8266. Is installed inside a board called the Node MCU D1 Mini, and it has all these pins that breaks out. So it's with all these called GPIO pins, general purpose input I/O pins, that we use to connect to our LED and make them light up or dim. So we'll go through that in a minute. The ESP8266 runs at 3.3 volts. However, we take the input from the USB. USB is at 5 volts, so there's some voltage conversion done by the board. And the whole thing is powered by USB, so you need to get a USB cable to connect this to your computer. The type of cable you need is the micro USB cable. First step is to insert the ESP8266 board. You have to line up the pin called 3.3 volts at the third column, like that. Then connect the red jumper wire according to the diagram on the left. So again, the Arduino program is not called program but called sketch. So this is the sketch. Another type of comment you can make is /* or /*. If you put in a /*, whatever follows will become comment, and until */. It's like a bracket, open bracket and close bracket. Whatever inside will be dimmed and will not be interpreted or compiled. So you can put in freestyle comments without needing to put in / every line. You can just put the whole paragraph of comment. This is usually good. You say who is the author, when you did it, what's the version, and a detailed description of your program. Okay, now let's go to the first effective line that the compiler will read, which is this #define command. #define is a compiler directive that tells the compiler this is a macro. Whatever I put in here is just a symbol, and when you compile, please replace this symbol red with the actual word D6. Same for yellow and green. So they will be replaced with D7, D5, and D6 during the compilation. This is useful if you want to replace some complex syntax with some simple macro words like red, yellow, and green. So D6 is the link in the ESP8266 that will be able to control a voltage, whether it's high voltage 3.3 volts or low voltage 0 volts or ground. And by controlling this voltage, you can control whether the LED connected will be light up or shut down. So we have D6 for the red LED, D5 for the yellow, and D7 for the green. Okay, next we have the first function of the program. A function means a group of instructions that can be referenced repeatedly from anywhere easily. So instead of typing the same command again and again, we can group it under a function, so we can recall it, reuse it as many times as we need without retyping all these repetitive codes. Void light bracket is the starting of the function, and whatever after the bracket will be the parameter of the function. That means what we want the function to do, we can specify in the parameters. And then the close bracket means that's the end of all the parameters. The first parameter is boolean r. Boolean is a variable type. It means true or false. So r is the name of the variable. R means red. So do you want to turn the red LED on or off by saying true or false? True or false can also be represented by 0 or 1. So you'll find that we'll be using 0 and 1 instead of true or false here in the actual statement, like here. Light 0 means false, 0 false, 0 false, and 1 true. So we have the red LED, yellow LED, and green LED. Do you want to turn them on or off? By saying true or false. And then the last parameter is the number of seconds you want to keep this light situation. You specify it with an integer. int means integer. You can put in a number. 1 means 1 second, 2 means 2 seconds, and so on. Next, we start the open braces. The open braces in Arduino or C++ specifies that that's the starting of a block of code. Especially for a function, you need to start your block of code with the open braces and close it with closed braces. Otherwise, you get compilation error. So we use open braces to start any code in our function. the first code we put in is an if statement. If bracket out. Any condition with an if statement must be under bracket. Bracket out means if the red LED should be turned on or turned off, and out will come in as true or false, right? If it's true, then I will do a digital write followed by semicolon. Semicolon ends a statement in the C++ language. So I call the digital write function, which is already defined in the Arduino library, and to turn on the red LED or turn off the red LED. So the way the LED works is a little bit different. If you put in low, that means you want to turn it on. If you put in high, that means you want to turn it off. So that's why we are here saying if it's true that you want to turn it on, then we put a low voltage to that pin of the LED, and the result will be to turn on the LED. Otherwise, which is else, if you don't want to turn it on, we will send a high voltage to the LED. That means it will turn off the LED. The LED will not light up. So the same is done for yellow and green LED. Finally, we have the delay command, delay seconds. Delay second is the parameter we get, but we want to turn it into the milliseconds because the delay function counts by milliseconds. So 1 second equals 1000 milliseconds. So we are multiplying this parameter by 1000 and calling up the delay function to delay the number of milliseconds, resulting in this. Okay, so that's the first function. After that, we go to the next function, which is a special function called setup. And we put it in void setup bracket because this function has no parameter. It's the first function that the microcontroller will run after boot up, and it will be running only once. Again, we have the open places to start our block of code for this function. The first command we use is serial.begin. Serial.begin sets the baud rate of our serial monitor. The speed of the serial monitor is 74,480 baud, which means bits per second. So we can open our serial monitor like this, 2 serial monitor. And you'll find that already I've set it up to match the program's speed, 74,880. To match the program's serial port speed. Right. So, for example, if I press the reset button on my MCU, it will immediately display some startup message from the CPU, even if no code is running. Right. So these are startup messages from the CPU. You can clear the display by clear the output, and then let me press the reset button of the MCU again. The ESP8266, let me press it now. See, it is printing out some boot messages, like it's booting in this mode. The cause of the reset is number 2. We'll learn this later on. And then it is trying to load from this memory address. The program length is this, something like that, right? Check some, blah, blah, blah. Okay. And then the next line we have is to print a blank line. Print line, bracket means print a blank line. You want to actually skip a line because you see there's a lot of boot up code. We don't want our output to mix with this boot up code. All this boot up code, you may not have a carriage return here, so we want to skip a line to make our message clean and easier to see. And then we'll start printing our traffic light demo started message to say that our program has started. This is a debug message, so we can at least know what is happening with our program. Right? Even though it's hung somewhere, we can still see where it is. The next 3 lines is to set up the direction of that input-output pin. All these red, yellow, and green LED pins that we defined that are called GPIO, General Purpose I/O pins. Each one has can communicate only in one direction at any time. So we need to set the direction to the output. So the processor knows that we are using it as an output. When you put a 0 into the pin, it will give you a low voltage. When you put a 1 into the pin, it will give you the high voltage, right? So this is for outputs. And this red, yellow, green has been defined before as macro, so whatever defined it, we'll be replacing it with the D5, D6, and D7, the actual pins on the microprocessor board. Next, we'll call up the function that we defined previously, the light up function here. To shut down all the LED, we'll put in 0, 0, 0 for red LED, yellow LED, and green LED. To shut them off, and we wait 1 second. Just to clear off the background before we kick off the lighting sequence of the traffic lights. Next, we have another function called a void loop bracket. Loop is a very special function. It will be run multiple times, again and again, until someone shut down the processor or press the reset key. So the Arduino device works like that. When it's first put up, the setup function will be run once only, and then the control will be passed to the loop function, and then it will start executing line by line until the last line, and then the loop function will be called again. So it will repeat the first line again, second line, third line, fourth line, until the last line, and then it go back to the start. So the loop function will be repeatedly run multiple times. So you don't need to have a go to the beginning again at the end of the statement. It will be automatically repeated by the microprocessor. Okay, the first line will light up the yellow, the first line will light up the green LED. I put a comment here so you can see clearly. So we will light up the green LED for 3 seconds by calling this light function. Remember, we have the light functions defined here. First parameter is red, second parameter is yellow, the third parameter is green, last parameter is how many seconds you want to delay. So you have to turn up the green LED only and delay for 3 seconds. The next line we turn up the yellow LED, delay for 1 second. The third line we turn up the red LED, delay for 3 seconds. Last line we turn up the red LED, delay for 1 and the yellow LED, and then delay for 1 second. And then the program will repeat from the beginning. So this is the lighting sequence of the traffic light used in Hong Kong. If your country has different type of sequence, you can program it easily here by changing the parameters to suit your city. Okay, so next we are going to click this upload button to upload the code. The code is uploaded, and then the microcontroller is reset, and then you can see the traffic light sequence. Green, red, yellow, and then green again. And there you have it, the traffic lights with some simple connection and program. Next, we'll be doing a more complex project that involves the IoT and the sensors for temperature and humidity. So see you next time. In the meantime, please subscribe, like, and send to your friends.